Right now, you're traveling through space at over 400,000 miles per hour, carried by a star that's racing around a supermassive black hole. That black hole sits at the center of our galaxy, the Milky Way, and it's 4 million times more massive than our Sunday. Tonight, we're taking you on a journey from Earth to that monster's edge. Through stellar graveyards and gas clouds larger than entire solar systems, past stars being born and others being ripped apart. If you're ready to see what our galaxy really looks like, hit that like button and subscribe because we're about to dive deep. Prepare yourselves. We begin. Music. We start here on Earth, but this planet is not sitting still. Right now, our entire solar system is plowing through space at 67,000 miles per hour, faster than any rocket humans have ever built. You might think we're just orbiting peacefully around the sun, but that's only part of the story. The sun itself is dragging us along on a much wilder ride. Picture our solar system like a speedboat racing across an ocean. The sun is the boat, and all the planets are passengers getting pulled along for the journey. We're not just floating randomly through space. We're following a specific path around the center of our galaxy, completing one full lap every 230 million years. The last time Earth was in this exact spot in the galaxy, dinosaurs didn't even exist yet. But here's where it gets strange. As we race around the galaxy, we're also bobbing up and down like that speedboat hitting waves. Every 33 million years, our solar system passes through the flat disk of the Milky Way, then rises above it, then dips below it. Some scientists think these crossings might trigger mass extinctions on Earth. When we pass through the galactic disk, we encounter more cosmic radiation, asteroid fields, and gravitational chaos. Think of it like driving through different neighborhoods in a massive city. Sometimes we're in quiet suburbs with nothing but empty space around us. Other times, we're speeding through busy downtown areas packed with stars, gas clouds, and cosmic debris. Right now, we're in one of the quieter neighborhoods, which might be why life had a chance to develop on our planet. The strangest part is that we're not traveling alone. Our solar system sits inside a huge bubble of hot, thin gas that stretches for over 1,000 light-years in every direction. This bubble was carved out by massive stars that exploded millions of years ago. Their explosions swept away most of the dense gas and dust, leaving us in this relatively empty pocket of space. Without this protective bubble, Earth might look very different. Dense clouds of gas and cosmic radiation could have made it much harder for life to survive. We're essentially living inside the aftermath of ancient stellar violence, cruising through a cavern hollowed out by star death. As we look up at the night sky, we see the edge of this bubble in every direction. Those distant stars you see are mostly on the far side of our cosmic neighborhood, shining through the thin walls of our protective shell. We're like passengers in a glass submarine, traveling through the deep ocean of space. Our journey to the galactic center starts here in this quiet bubble of space. But as we venture outward from our solar system, we'll discover that our peaceful neighborhood is surrounded by forces and structures that dwarf anything we see from Earth. The first of these cosmic landmarks lies just beyond our protective bubble in regions where gas and dust begin to thicken and new stars are being born in spectacular fashion. The bubble of space around us has a name among astronomers: the local bubble. This cosmic cavern stretches over 1,000 light-years across, and we're drifting through it like a speck of dust in a cathedral. But this cathedral was carved by violence. About 10 to 20 million years ago, a group of massive stars lived and died in this region of space. When stars over 8 times heavier than our sun reach the end of their lives, they don't fade away quietly. They explode as supernovas, releasing more energy in seconds than our sun will produce in its entire 10 billion year lifetime. These explosions didn't happen just once. They happened over and over again as star after star in this region reached its violent end. Each supernova blast swept outward like an invisible tsunami, pushing gas and dust away from the explosion site. When multiple supernovas go off in the same region over millions of years, They create what astronomers call a superb bubble. Our local bubble is one of these cosmic hollows, still expanding outward from those ancient explosions. Imagine throwing stones into a calm pond. Each stone creates ripples that spread outward in circles. Now imagine throwing dozens of stones into the same area over and over again. The overlapping ripples would create a complex pattern of waves and calm spots. That's what happened here. Except instead of stones and water, we're talking about stellar explosions and the fabric of space itself. The walls of our bubble aren't empty. They're made of hot gas heated to over 1 million dig by those ancient explosions. This gas is so thin that a cubic inch contains fewer atoms than the best laboratory vacuum on Earth. Yet it glows with X-ray light, invisible to our eyes, but detectable by space telescopes. We're not at the center of this bubble. Our solar system is actually closer to one edge, drifting toward a region where the bubble wall is starting to thicken with cooler gas and dust. In about 5 million years, we'll punch through this wall and enter a much denser part of the galaxy. When that happens, our solar system will face new challenges. The thin bubble of hot gas around us acts like a shield, deflecting some of the cosmic radiation that would otherwise bombard Earth. When we leave this protection and enter denser regions of space, our planet's atmosphere will encounter more high-energy particles from deep space. Some scientists wonder if this could trigger climate changes or even mass extinctions. For now, we're sailing through this cosmic safe harbor, protected by the aftermath of stellar death. The irony is perfect. The same explosions that could have sterilized any planets in this region millions of years ago now provide a buffer zone that helped life flourish on Earth. But our peaceful journey through the local bubble is about to encounter something extraordinary. Just ahead of us, in the direction our solar system is traveling, lie the stellar nurseries where new stars are being born. Just 400 light-years from Earth, something magnificent is happening in the darkness. Giant clouds of gas and dust are collapsing under their own gravity. And deep inside these cosmic cocoons, new stars are igniting for the first time. The nearest star-forming region to us is so active that if our eyes could see infrared light, it would glow brighter than any star in our night sky. This stellar nursery is called the Orion Molecular Cloud Complex, and it's a factory for making suns. Picture a cloud of gas and dust, so vast that light takes several years to cross from one side to the other. Now imagine that cloud slowly contracting like a giant hand squeezing a sponge. As the cloud shrinks, it heats up. When the center gets hot enough, nuclear fusion begins and a new star lights up for the first time. But star birth is not gentle. When a new star switches on, it blasts out winds of particles at speeds of hundreds of miles/. These stellar winds carve bubbles and caverns in the surrounding gas cloud, creating structures that look like cosmic sculptures. Some of these newborn stars are so massive and energetic that they illuminate entire sections of their birth cloud, creating glowing nebulas visible from thousands of light years away. The process takes millions of years, which sounds long until you realize that most stars will shine for billions of years. It's like watching a flower bloom, except the flower is bigger than our solar system and will burn brighter than 1,000,000 suns. Not every clump of gas becomes a star. Some collapse partway and become brown dwarfs, failed stars that glow dimly in infrared light. Others get torn apart by the winds and radiation from their more successful neighbors. What makes this even more remarkable is that stars are not born alone. When a gas cloud collapses, it usually fragments into dozens or hundreds of pieces, each becoming its own star. These stellar siblings start life clustered together in tight groups, sharing the same cosmic neighborhood. Over millions of years, they gradually drift apart as gravity from the rest of the galaxy pulls them in different directions. Our own sun was born this way in a cluster with thousands of other stars about 4.5 billion years ago. Those stellar siblings are now scattered across the galaxy. Impossible to identify because they've traveled so far from their birthplace. Somewhere out there among the hundreds of billions of stars in the Milky Way are the long-lost brothers and sisters of our sun. The star formation happening in nearby regions gives us a window into our own origins. Every element in your body, except hydrogen and helium, was forged inside a star and scattered into space when that star died. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it came from stellar furnaces that burned billions of years ago. You are literally made of star stuff assembled from the ashes of cosmic giants. These stellar nurseries are just the beginning of our galactic journey. As we venture further from Earth, we'll encounter the larger structure that contains these star-forming regions. Our solar system doesn't live in just any random part of the galaxy. We're embedded in a structure so vast that early astronomers had no idea it existed. The Orion Arm, also called the local arm, is a minor spiral arm of the Milky Way that stretches for thousands of light years in both directions from our position. We're not just riding along with this structure, we're actually woven into its fabric. Think of the Milky Way galaxy like a massive hurricane seen from space. The bright spiral arms you see in pictures are like the storm's bands of clouds, except instead of water vapor, these arms contain stars, gas, and dust. Most galaxies have 2 or 4 major spiral arms, but they also have smaller arms and spurs branching off from the main structure. The Orion Arm is one of these smaller branches. For decades, astronomers thought we lived in a tiny spur connecting 2 major arms. But recent observations have revealed something surprising. The Orion Arm is much larger and more substantial than anyone realized. It extends for over 20,000 light years, making it a significant galactic feature in its own right. We're not living in a cosmic backwater. We're part of a major galactic highway. This spiral arm contains some of the most famous objects in our night sky. The bright stars of Orion, Perseus, and Cygnus all belong to our local arm. So do many of the stellar nurseries where new stars are being born, including those vast molecular clouds we just explored. The arm acts like a gravitational river, channeling gas and dust into dense streams where star formation can occur. But spiral arms are not permanent structures. They're more like traffic jams on a cosmic highway. As material orbits the galaxy, it gets bunched up in certain areas, creating the appearance of spiral patterns. Stars and gas clouds flow into the arms, spend some time there, then flow back out into the spaces between arms. Our solar system has probably drifted in and out of spiral arms multiple times during its journey around the galaxy. The density difference between arms and the spaces between them affects star formation rates across the galaxy. When gas clouds enter a spiral arm, they get compressed by the increased gravitational forces and higher densities. This compression can trigger the collapse of gas clouds into new stars. Then, as massive stars form and eventually explode as supernovas, they can disrupt nearby star formation or trigger even more stellar births. We're currently positioned about halfway between the galaxy's center and its outer edge in what astronomers call the galactic habitable zone. This might not be a coincidence. Closer to the center, there's too much radiation and gravitational chaos for stable planetary systems. Further out, there aren't enough heavy elements to build rocky planets like Earth. Our location in the Orion Arm puts us in a cosmic sweet spot. As we journey deeper into the galaxy, we'll leave our familiar local arm behind and encounter the much more massive structures that dominate the inner regions of the Milky Way. Hold on to something, because the numbers we're about to share will change how you think about motion forever. You're not just sitting there reading this. You're racing through space faster than a rifle bullet, faster than a jet fighter, faster than anything humans have ever built. And that's just the beginning of your cosmic speed. Right now, Earth is spinning on its axis at over 1,000 miles per hour at the equator. That's your first layer of motion. But Earth is also orbiting the Sun at 67,000 miles per hour, carrying you along for the ride. Most people know about these motions, but they're nothing compared to what comes next. Our entire solar system is orbiting the center of the Milky Way galaxy at 514,000 miles per hour. Let that sink in. Every second you travel over 140 miles through space just from galactic rotation. If you could somehow step outside this motion and watch our solar system pass by, we would streak past you faster than a beam of light appears to move to the human eye. But even that's not the full story. Our galaxy itself is moving through space. The Milky Way is falling toward a massive galaxy cluster called the Virgo cluster at over 1 million EV. And the Virgo cluster is being pulled toward an even larger structure called the Great Attractor at incredible speeds. When you add up all these motions, you're traveling through the universe at roughly 1.5 million miles an hour. Think about this. In the time it takes you to read this sentence, you've traveled hundreds of miles through space and you never felt a thing. There's no cosmic wind in your hair, no sense of acceleration. You're surfing through the universe at mind-bending speeds. And the only reason you don't feel it is because everything around you is moving together. This galactic motion has consequences beyond just impressive numbers. As our solar system orbits the galaxy, we encounter different environments. Sometimes we pass through the galaxy's spiral arms, where star formation is active and radiation levels are higher. Other times we cruise through quieter regions between the arms like we're doing now. Our orbital speed also means we complete one full trip around the galaxy every 230 million years.